Okay, so this question's reviewing vector components. Pilot heads her plane with a velocity of 225 kilometers per hour north. There is a strong wind of 112 kilometers per hour due east. What is the velocity of the plane referencing ground, like compass directions, essentially? Okay, so I'm looking for what's the resultant velocity of the plane using the compass directions you were given. So let's have a look at this one because it's pretty quick. Okay, so the person heads north, okay, 225 kilometers per hour. There's a wind blowing due east at 112 kilometers per hour. Okay, that means that the resultant velocity is like this. The plane will be blown slightly off course, okay, to the east. And that will be our resultant velocity, and we'll need the angle for that because velocity is a vector quantity. Okay, so to find our resultant v is a Pythagorean theorem calculation. 225 squared plus 112 squared. Okay, will give us 251 kilometers per hour. And then to get our theta, okay, opposite over adjacent. So we'll have tan to the minus 1 of 112 over 251, okay, and that should give us our 26.5 degrees east of north. Okay, everybody all right with that one? Okay, not much different obviously than what you were doing on your map activity with perpendicular vectors. Okay, all right. That one I want you to try. Another boat question. We talked about those on Friday last week, but we haven't done one since. Okay? So, draw the river. Okay? Remember, there's two types of boat questions. Rowing across and going across. This one wants to go across. Okay, it says, wants to travel north, perpendicular to the river current. That means that's what they want to end up doing, okay, is going due north. And if I want to end up going straight across, I got to aim a different way. You guys got to figure out which way. Okay, so this is a question where we are going across. All right, that means our resultant is going to be straight across the river. Okay, that's my resultant. That means the two vectors that add up to it start one from the tail and the other one meets the head. Okay, so I've got a river current, okay, that is going east at 1.2 meters per second. Okay, I know I drew that head to head, but remember that black line is my resultant. It's what I'm looking for. Okay, the other vector, okay, I know has to go this way because if I'm trying to row across a river, I have to aim somewhat upstream, somewhat into the current, so the current pushes me back to straight. Okay, so this is actually my rowing speed here, which they told me is 3.0 meters per second. So all I need to find is my angle. Okay, so it's just a matter of interpretation. That's actually the hardest part of this question, is interpreting it and getting to the point where I can now do a simple trigonometry calculation. Okay? I have in this question the hypotenuse and the opposite side of the angle that I'm looking for. And all I'm asked to find is the heading. Okay? So theta will be tan to the minus 1 of 1.2 over 3. Okay? And that should give me 24 degrees west of north. Okay? That ringing a bell for both questions. Okay? The other way we could get one of these is, I'm rowing straight across, how far downstream do I end up? Okay? This one says you don't want to go downstream. Okay? So you know it's the other guy.
Shouldn't it be signed?
Sorry, it should be signed, yes. I'm so used to using tan. Good catch, Davis. Sign to the minus 1. Absolutely right, yeah. Okay, any other questions on that one? Any other mistakes to be pointed out? You should point them out if I make them. It doesn't hurt my feelings or embarrass me, because I'm old and I'll forget by this afternoon. Okay, so a boat is traveling directly north across a river at a velocity of 1 meter per second. The river flows 0.50 meters per second east. Again, what direction is the boat headed? Just like the last one, okay? See if you can get it this time, if you didn't get it last time. Okay, we've got the river. Okay, we want to go straight across it. Okay, but this time, okay, they want to row directly north at 1.0 meters per second. So they're actually telling us this is how fast they want to go as well. Okay, the river's flowing east at 0.5. Okay, what direction is the boat headed? Well, boat's headed in that direction. Okay, we're going to get 27 degrees west of north on that. Okay. All right. And that's another one that's just like that one, so we'll skip that one. Okay, this one is the other kind of boat question. Okay, so you're not going to end up going straight across this time. The resultant's going to be somewhat downstream, and you have to find out how far downstream you get, how long it takes you to get across, okay, all of that kind of stuff. All right, so I want you to try that one. A boat can travel at 4 meters per second on still water. That means that's how fast you can row it, okay, and it's headed directly across the river. Not going to end up going that way, but that's the way it's headed. Okay, and the river is 125 meters wide. The river current is 2.1 meters per second east. Okay, so you know the river is 125 meters wide. Okay. Give you a few minutes on that one, you know. Okay, so we have a 125 meter wide river. Okay, they are heading across at 4.0 meters per second. The current is pushing downstream at 2.1 meters per second. So our resultant velocity is this side, okay, the hypotenuse of the triangle. All right, so first thing we got to do is find that, okay? That's just a Pythagorean theorem calculation and a trig calculation. So 2.1 squared plus 4 squared, okay, will give us our 4.5 meters per second. Okay, everybody all right with that part? Okay. If we want to find the vector, okay, theta will equal tan to the minus 1 of the opposite side, 2.1, over the adjacent side, 4, okay, giving us our 28 degrees east of north. Okay, so now I've calculated that. I'm never going to use that number again. The question just asked me to calculate it, but I don't use it for any of the following questions because it doesn't point across and it doesn't point downstream. It's the average of both. Okay, so it can't tell me anything about how far downstream I go or how long it takes me to get across. Okay, it doesn't do that. So I'm going to go back to the numbers I have. I have a velocity that's pointing straight across and a distance that is straight across. Can I use them together? I sure can. I can't use this number, the 4.5, with this number because they don't point in the same direction. Okay? They're not speaking the same language. Right, so I have to use numbers that go together. So the first thing they asked me to find is how long does it take to reach the opposite shore? Well, I'm going across at 4 meters per second and it's 125 meters across. Okay? Now probably a few of you are going, yeah, but Coderre, you're not going straight across. You're going downstream at the same time. Yep, you're right. But that actually doesn't change how fast I get across. It just changes where I end up when I get across. Okay? I'm still rowing across the river at 4 meters per second and it's 125 meters across. These two things are happening concurrently. Okay, that is at the same time. So to find the time, T equals D over V. Okay, so if I had my distance, 125 over, over 4, okay, that'll give me my 31 seconds. Okay. Now that I know it's going to take me 31 seconds to get across, I also know how long I'm going downstream for. Do I know how fast I'm going downstream? 2.1 meters per second. So now I can take this time, because time is scalar, it can apply to another one of my vectors, okay, the 2.1. So to figure out how far downstream I go, d equals v times t, 2.1 times the 31 seconds is going to give me 66 meters downstream. Okay, so I know this looks a little bit weird, and it probably sounds weird when I say to you, even though I'm going at an angle, I'm still moving across the river at the speed I'm rowing. Okay? I know that might seem weird, but here's the thing. If I had a person on a lake with no current, same person, okay, rowing at 4 meters per second, it would take them the same amount of time to row 125 meters as it takes this person to row 125 meters. Okay? The fact that I'm in the river doesn't make any difference when I'm talking about going across and going downstream. This doesn't affect this because they're perpendicular. Okay? If I pointed into the current, would it slow me down? It would. But because I'm rowing straight across, no component of my rowing is in the same direction as the current, so they don't affect each other. Okay? They don't make me go slower or faster. Sure, they add up to this, but it doesn't affect how fast I can row. Okay? But if I point into the current, then my result will become shorter, because now I do have a component that is pointed into the current, and it's going to shorten it. Okay? Everybody with me there? All right. Anybody still need that one? Okay, this one's a boat question, but it's not a boat question. It's a vector components question. Okay, so we got a boat that sails 150 kilometers, 20 degrees east of north, then sails 265 kilometers, 45 degrees south of east. Okay, we're looking for the total displacement, and then if that takes 12 hours, we're looking for the velocity afterwards. So a quick v equals d over t after. Okay, but for right now, see if you can find the overall displacement using vector component addition for part A. Okay, just going to put the diagram up here, guys, so you can see if you've got the diagram right. So 150 kilometers, 20 degrees east of north. Okay, so I'm going to draw a line here that's north, going to go 20 degrees east of that. There's X, there's Y, and this is 150 kilometers. Okay, and then we have 265 kilometers at 45 degrees south of east. Okay, now, if I draw this 45 degrees and I make it the right length, it's hard to tell whether I'm going to end up past where I started north-south or end up short of where I started north-south, right? So what I'm going to do before I draw that triangle is I'm just going to kind of draw a small version of it. Okay, and I'm going to figure out what X and Y are. Luckily for me, X and Y are going to be what? The same, because it's a 45-degree triangle, so I can save myself some time here. I just want to know if I need to make this thing go past where it started, so down here, or not past where it started, up here. Okay, so I'm just going to go sine of 45 okay, times 265. All right, so it's 187. Okay, so it's going to go down 187. I can already tell that that's going to get past here. Without having calculated black Y here, okay, I can tell it's going to get past. How can I tell? Because it's longer than the hypotenuse of this triangle. That's how I can tell. Okay, my north-south component, in this case south, is longer than this line is. So it's definitely longer than this line. Would everyone be okay with my logic there? Okay, so I'm going to draw that in now, 45 degrees. Okay, below where I started. Sorry, my triangles are also crooked. Okay, 45 degrees. This is 265 kilometers. Okay, here's X, here's Y, and I already know how long these are because I just calculated it, 187.3. Kilometers south, 187.383, 296. Okay, so there's my overall diagram and a couple of the x's and y's calculated. Okay, there's my resultants. Alright, keep going on that one. Okay, let's have a look at the rest of this one. So we still have to find black y and black x from our first vector here so that we can find our overall resultants numbers. Okay, so black x is opposite the 20-degree angle, so that's going to be sine of 20 times the hypotenuse, which was 150. Alright, so we're looking at 51.303. And that's kilometers east. Okay, and then black y is adjacent, so it'll be cos of 20 times 150. Okay, so we're looking at 140.954 kilometers north. Okay, so now I've got all my x's and all my y's. Now I can find green x and green y. So green x, okay, is going to be our 51.303 plus 187.833. Okay, so I'm taking this number and this number, I'm adding them together. That'll give me black x, or sorry, green x. Okay, everybody with me there? Okay, so green x then. Oh, I missed a zero. Plus 187.383. Okay, so we're looking at 238.686 kilometers, and that's east. Okay, and then when I want to calculate green y, I'm going to take the 150, sorry, not 150, the 140. 0.954. Okay, so that's this one, and I'm going to add it to this one over here, except that red y is negative because it's south. Right, so I'm going to go plus negative 187.383, or 833, sorry. Okay, so we'll take our 140.953.831 and subtract our 187.83297. Okay, so we're looking at 46.879 kilometers south. Okay, so now that I've got the two sides of my displacements triangle here, I'm going to find my displacement using what? How do I find my next one? Okay, I'm looking for the hypotenuse of this triangle. How do I find it? Right, Pythagoras, a squared plus b squared. All right, so overall displacement is going to be our 140 squared plus our 46 squared, obviously with all the decimals punched into the calculator. So square root of our answer squared, plus our 238. Sorry, I said 140, but it should be 238. It's the big line. 238.665 squared. Okay, so we're looking at 243.2. We only have two significant figures in this question? Yes. So we're looking at 2.4 times 10 to the 2. meters, and then we need the vector, okay? The way I drew this, that's gonna be x over y, okay? So theta will be tan to the minus 1 of 238 over 46. Obviously, again, with all the decimals in place. Divided by 46, 87907. Okay, so we're looking at 78.8. I only have two significant digits, so 79 degrees. And that'll be east of south. Okay, so my final answer for my displacement is 2.4 times 10 to the 2 meters at 79 degrees east of south. Right. Now, the second part of this question asked me to calculate the average velocity if this takes 12 hours. All right, now here's the thing you need to know about a part A to a part B. I have come up with my answer to the correct number of significant digits for part A. Part B requires me to use that number to do a calculation. Therefore, I use the rounded value. Okay? Everybody follow me there. And because I'm actually using the answer from part A, I use the rounded value of part A, okay, to answer part B. All right, so for part B here, we've got V equals D over T, so that'll be our 2.4 times 10 to the 2 divided by 12 hours, okay, which is going to get us our 20.3 kilometers per hour, okay, but actually you should only have two significant digits. I don't know why all these have three. They shouldn't, okay, so it'll just be 20 kilometers per hour at the same vector, okay, velocity and displacement have the same vector, so it'll be at 79 degrees east of south. Okay. All right, that's as long and as involved as you would encounter one on like a quiz or something like that. Okay, angle vectors all over the place with that one. Okay, so coming up here, guys, like I said, Friday we're going to have your assignment on vector additions, 10 problems. Okay, some of them are super easy, like just finding vector components, some boat questions, and some questions like this, okay, but there'll be 10 of them. Right? So we'll be going over that, having class time to work on that on Friday, and then Monday projectile motion, Tuesday projectile motion, Wednesday projectile motion, Thursday projectile motion, okay, and then Friday unit exam review, for you to ask questions and such, and then exam on October 5th. Okay. Remember that I'm available at lunch every day, okay, for help, so pop in and ask if you need it, okay, figure out some questions to ask me, okay, before then.